Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of attributes of quadratic function graphs. This is standard A.7A in the great state of Texas, and we are using item number 25 of the 2024 released STAAR test. This is a new item type called drag and drop, and if you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So before we get into this problem itself, let's take a look at how we're going to answer it. It's drag and drop. There are two boxes, so this is a 2-point problem. But you notice we've got two words, and you notice that I can't place this word minimum. It shows up blue there. I can't place it in the second one, neither with maximum. So my first drag and drop has to be either minimum or maximum. And then you'll notice these numbers cannot be drawn over here to the left. They have to go to the right. So we are looking for a minimum or a maximum value of something. And if I move on with just half of it, it is going to give me an error message. So what do we know about this quadratic function? Well, we know a lot of things. We don't necessarily know what the equation is that best represents that, and we're not asked to figure that out. We could if we needed to. What do we know? Well, we know a few different things just by looking at this quadratic function graph. Right, so we can say that this is a parabola here, and we could say one thing. It's not what we're asked for, but we can say it's the axis of symmetry. So where is the line that if we were to fold this in half, each half would lie perfectly on top of the other, and it's going to be on this dotted line here that I've got this x equals -1. Okay? We know that. We also can figure out what the solutions. So we call them solutions. Sometimes we will call them zeros. Or sometimes we'll just call them the x-intercepts. They really all refer to the same thing. Where does this graph cross the x-axis? And you see we've got two of them right here. All right, so I've got solutions of -3. We would use this if we wanted to write this in factored form, right? And then we would say 1. All right, so I've got two solutions or two zeros or x-intercepts. Now, we're not looking for either of those because as you can see here, the only two options we have for this first one is either minimum or maximum. Okay, so if you're not sure which one is which, right, you can think of this prefix mini. So if something is mini, like a mini skirt, or if you play video games, might be a mini gun. Typically that means small. And then this max, right? Max means large. If you're driving down the freeway, you might see a max speed limit sign, and that means that's the top or the largest speed limit that you can legally go. So when we're looking at this, does this graph have a minimum or a maximum? Well, these arrows right here let me know that these continue on forever. So if my max is up here, and then my min is down here, there is no max. It's just going to go on forever and ever and ever. But does this graph have a bottom? Yes, it does. It has a bottom right there. I'm going to draw that line to show you that's as far down as it goes. So it does have a minimum. Now, what is that minimum? Well, we've got that line right there. And really, we are just looking for what is that y value that our graph will not go down below. And as you can see, it is right there. And that is going to be on my -4. So we're going to grab this over here, and we're going to say the function has a minimum value of -4. It doesn't have a maximum value because those arrows mean it goes on forever. So that's going to be a 2-point problem. And we simply identify that the function has a minimum value of -4.